Okay, let's continue first order systems. Okay, now we want to see the effects of the inputs to the system's response, right? Okay, let's say we have a system's 1 over s plus 1 again. Okay, let's say input is r of s, y of s. Okay, we need to see what is the effects of the inputs to the system response. Okay, so we will supply three different inputs to the systems, which is R1. Look at the slide. R1, the input 1 is 1 over S, R2, 2 over S, R3, 3 over S, right? So we're going to apply to the same system, which is 1 over S plus 1. And then we need to see what is the response, and then the parameters on the response side, right? Okay, you see from the response in the slide, the response represents the input 1 over S. The blue color one is the response for the input 2 of S. And then the yellow color one is the response for the inputs 3 of S. Okay? But you see the response, even though the response looks different, but the parameters such as the the time constants, the settling times, even the rise time, they are the same, right? Because that parameter, that three parameters are actually belong to the system, not to the input. Regardless of any inputs, the response, the parameters will be the same, but the only things that change is the steady state. Okay, the steady state will change according to the inputs. If the input is higher, the steady state will be higher, right? Okay, let's see this. I'm going to show you very quickly. So it is, we have three inputs, R2, R3, okay, 3 of S. So we're going to input this to the system's RS, then we need to see what the parameter will change, right? So, so Y of S, that will be 1 of S. So this is our R of S. Then our system would be 1 minus 1 e to the t. Okay. So you see there is a minus t, this is a 1t, right? That 1t, right, actually taken from here. No, taken from here. 1 over 1 here. Okay? Taken from there. Okay, then we'll have this one. Let's represent the response, the red color response. Alright? Then if we apply 2 of S, right, the same thing, that will be 2 minus 2e to the minus 1t, right? So if we calculate, we're going to, in term of the t tau, time constant, rise time and settling time, they'll be the same, right? And try 3 of S, 1 over S plus 1 is 3 minus 3e to the minus 1t, right? So all these three actually will produce the same response, but different in steady state, right? So meaning that by looking at the transfer function here, right, we should be able to determine the time constant, rise time, and settling time. right? Without having to convert to this time domain. Okay, what we're going to do is that, okay, whatever transfer function that we have here, regardless of any inputs, we can find these three parameters, right, from here. So what we're going to do is we're going to convert this into a standard first order system, which is tau plus 1. Okay, this is a standard form of first order system. Okay, standard form of first order systems. Alright, so we have that. Then whatever transfer functions that we have, we're going to change to this form. Okay, for example, if we try to do this one first, okay, because the important here is we need to find the tau, and then once we know the tau, we can find the rise time, we can find the settling time. Okay, so because from the previous example, right, we know that 1 of s plus 1, whatever input that we supply here, we will get the tau equal to 1 second. Settling times is equal to 2.2 seconds, and this rise time. Settling times is equal to 3.91 second, right? All right. Because of this, okay. If we assume that this is our tau, which is consider 1, this is 2 tau, 3 tau, and 4 tau, right? This is our response. Because we know that the t equal to 1 is here, which is 63.2%. Okay? And then we know that the rise times is somewhere 2.3 here to 0.1 here, which is 0.1 t. In this case, this is 2.3 t. So we can find that t r equal to 2.2 tau. So this is tau, right? And then tr 2.2 tau, regardless of any transfer function, ts will be somewhere here, 3.91 tau, right? So because settling time is anything that above 98%, we consider that is a time that is the where the response is at steady state. So we can use this 3.91 tau as a settling time, or we can simply put 4 tau. Okay, so this is the formula that we have, right? So next time when we have a different transfer function, we can simply calculate regardless of any inputs, and then we don't have to. Very important that we don't have to convert them into the time domain as we did before, right? Okay, so you see from the slide there are 3 responses, and then the first one is 1 over s, second 2 over s, and the third one is 3 over s, the input. But the time will be the same, right? So the system doesn't change, the system response doesn't change the parameter of the first order systems, but it rather change the steady state only, right? Okay, now, so we need to see if, let's say, we have a different systems, different first order system, right? So example, you have 3 2s plus 5, say, right? So this is our new systems. So from here we need to find what is the response parameter, right? The tau, the rise time, and the settling time. So again, as I mentioned earlier, we have to convert this into a standard first order systems as tau plus 1, right? So we have to make this 1. So what we're going to do is we're going to divide this by 5, okay? So this, in order to conform to this standard form, so we need to make sure this part here 1, right? This one here 1. So we're going to divide this by 5. This one we're going to divide this as 2 over 5 plus 5 over 5, right? So this is our new form, okay? So if you compare this, you will have this terms here equal to 1, which is equivalent to this, and then here is our tau. See that? This is our tau, 2 over 5, right? So we don't really worry about this. This is just a gain because it will determines what is the steady state value for the system depending on the input, right? So from here, we can simply determine what is the time constant, which is 2 over 5 seconds, right? And then from knowing these the values here, we can find Tr, which is equal to 2.2 multiplied by tau, right? So we have this, okay? And then Ts, we have 4 or 3.91, make it 4, multiplied by 2 over 5, we have this, okay? So let me calculate this. So Tr which is 0.88 second, right? This is going to be 0.4 second. Ts is this is 1.6 second, right? So we have all these parameters. Then we can just to validate the parameters for the response. We know that the response can be like this. This is the steady state. We can calculate from here, which is this is going to be e to the minus 5t, right? So we can solve this to find the steady states. Okay, whatever it is, so we can find the tau equal to 0.4, Tr equal to 0.88, right? And then Ts 1.6 second. Okay. All right. I think that's the end of the first order systems. So very important things to remember is that the first order systems is consists of the first derivative terminate, right? And then the response, I mean the output response is always overdamped, right? And there are three parameters in a first order response, which is time constants, rise times, and then settling time, right? So how do we calculate those parameters? I already show you. So now I think it's good if we can, do some exercise. I'll give you a few examples. You need to do it at home because very soon we're going to have a quiz, online quiz, but not now. So I'll show you, I'll give you a few examples for you to try yourself, and then if you have any problems, please let me know. Okay, the first one, maybe you try systems. Maybe just draw a block diagrams, it's easier. 3s plus 10. This is our ys. This is r of s. You need to try, the input is 1 over s, 3 over s, and maybe 10 over s. Okay. Number 2, we have a second systems. Okay, this is 1, maybe s 0.1 plus 5, yeah, s 0.1. So you need to apply, maybe in this case you just apply step input 1 over s. Okay, number 3, yes, r over s. We have a simple system s plus 1, but this time you need to apply, there's a impulse input rs equal to 1, or in RT we called it 1d, right? So this is impulse input, and then try the impulse input maybe 5. Okay, and then okay, for all these example questions here, you need to determine A. For all of these, you need to determine the time constant tau. You can use the first method and the second method, right? Because the first method we use a time domain, and then we can calculate the parameters based on the response. The second one, we just look at the we just convert this into the standard form, and then we find the parameters, right? So this is rise time, TRC, settling time, TS, and then probably for all of this you need to sketch the response. Okay, it's important for you to try this, because if you don't try, you don't know, how to solve how to get the parameters from the response. Yeah. So I think we finished the first order system. So the next one I will start with second order system. All right. So make sure you